In our last video, we said that OP mainnet is an optimistic rollup. Now, what does that exactly mean? How do rollups work? Rollups are typically defined as layer 2s, as blockchains that inherit another blockchain security. In the case of OP mainnet, that blockchain is, of course, Ethereum. Now, the truth is somewhat different. Most layer 2s in the ecosystem are not really inheriting Ethereum security. Security is like a big word. They inherit some things from Ethereum, but they are not as secure as mainnet. People normally say that rollups are on training wheels. They are designed to be as secure as Ethereum, and they are a great way to scale everything by executing transactions off-chain and just getting the same level of security, but they are not really there yet. The system has been thought of, but not entirely built. So let's see what happens exactly on OP mainnet. In this video, we will understand how block storage, block production, and block execution is happening in OP, and also we will see the fault proofs, which are key to this idea of inherent security. Let's begin with block storage. OP mainnet is a rollup, and it is also a blockchain, right? It has its own blocks. Now, all the information from the blocks is posted into Ethereum. Remember the idea and the analogy with the bar? It's not that you just go and pay and nobody sees what happens. You pay all the beers together and you get the receipt for that payment, and that payment gets posted into the information of the bar system. So let's say we have all these transactions and all these blocks of the layer 2. All that information is compressed and sent to Ethereum using transactions call data. So that is why we say that layer 2s, specifically OP mainnet, inherits the data availability and the data integrity of mainnet, of Ethereum, because all the information is there saved as transaction call data. You get to execute as many transactions as you want. It's much cheaper, but then you post the results so everyone can see them. Now, how are these blocks produced? Here comes one of the main security assumptions that we have to make when trusting in OP mainnet. Blocks are produced by a centralized sequencer. The sequencer receives the transactions, creates the blocks, then gives everyone else all the information on the blocks, and most importantly, posts that information into mainnet. So this process of just getting things executed off chains and then into Ethereum is done by a centralized sequencer. This is a centralized sequencer run by the Optimism Foundation, and this is one of the key security assumptions we are making. Now, remember when we talked about retro PGF and the virtuous cycle? Well, I think we are now connecting the dots, right? The centralized sequencer is getting all the revenue, is getting all the fees that people pay when they use OP mainnet, and those fees are being reinvested into retro PGF. So we have investment in public goods, which is going to attract more builders and more users. They are going to use the chain. They are going to create more fees for this centralized sequencer that is creating the blocks and then posting them in mainnet, and then all those fees will be reinvested in more public goods and more builders and everything. There is also a second point we need to raise on this, and it's censorship resistant. What happens if the sequencer is censoring your transaction? Well, you have another choice. You can go and get your transaction executed through mainnet, through Ethereum, through the layer 1. In that way, we manage to give OP mainnet the same level of censorship resistance of Ethereum. If the sequencer is censoring you for whatever reason, you can still get your transaction through. Time to move to the execution. Of course, the sequencer has to execute all the transactions. It's very similar to miners in Bitcoin or to validators in Ethereum, but also similar to Ethereum, where you have all the nodes that are not validating but are seeing the transaction and executing them and making sure everything is alright. In Optimism, you have the rollup nodes that can derive the blocks and the transactions from mainnet, execute them, and make sure everything is correct. So that is really the real reason why we need to have all the information posted to the layer 1, because we have to trust the sequencer, yes, but we can go to the L1, we can go to Ethereum, we can derive the blocks from there, and we can validate all the transactions. The question is, what happens if we find out that the sequencer is abusing the system? Let's say the sequencer is, for example, taking 2000 OP that belong to Mick Jagger. How are we gonna deal with that? And here is where we have the training wheels. The system is designed to work with fault proofs, but the fault proofs are not already built. So we need to trust that the sequencer is doing things right. However, it's important to understand how fault proofs are supposed to work So let's go see them. For proof work together with a challenge window. Every time the sequencer posts information into mainnet, a 7-day challenge window opens. Now during that period of time, everyone can go to mainnet, derive the transactions, validate everything, and if they find something that's not correct, not appropriate, if they see that the sequencer is abusing the system in some way, they can go and submit a false proof. There will be like an endless discussion between the sequencer and the challenger, like, yeah, this is not okay, no, yeah, this is okay, until somebody realizes that we have all the information in Ethereum. So we can just go and check what happened, we can execute the whole process and see if the sequencer is effectively cheating or if the challenger made a mistake when accusing the sequencer. Again, that is the key point of data availability and data integrity. As long as we have the information on chain, and as long as we have people interested in reviewing that information and validating the transactions to check that the sequencer is doing a good job, and when we have the foolproof systems to get all this debate settled, we can trust that what's happening in OpenMainet is gonna be alright. For now, we need to trust the sequencer and we need to trust the Optimism Foundation in their running the chain. Luckily, there are many great teams working on building the foolproof systems, so maybe by the time you're watching the video, it's already done. Of course, the foolproof system is gonna be a key ingredient in the OP stack, and that's exactly what we will be talking about in the next video. Information on chain. And as long as we have people interested in reviewing that information and validating the transactions to check that the sequencer is doing a good job, and when we have the foolproof systems to get all this debate settled, we can trust that what's happening in OpenMainet is gonna be alright. For now, we need to trust the sequencer and we need to trust the Optimism Foundation in their running the chain. Luckily, there are many great teams working on building the foolproof systems, so maybe by the time you're watching the video, it's already done. Of course, the foolproof system is gonna be a key ingredient in the OP stack, and that's exactly what we will be talking about in the next video.